This conference will now be recorded.
To introduce myself, Ravinder. I'm working on Postgres more than 7 years now. I'm working on, Microsoft SQL Server since more than 17 years. I'm working on MySQL. We do work on AWS. I do work on Azure. I do work on MongoDB as well. I'm leading a technical team. There are many technology people report to me. This is a little introduction about myself, a technical background kind of. So today we're going to talk about the agenda of today's class is all about informational, most of informational, but very helpful to know about the Postgres. In fact, so we will first talk about in the agenda Postgres history. Before learning any product, knowing the history is really good, basically. So I'm going to cover the history part first, then features of PostgreSQL. So what are the features are really outstanding in RDBMS era? Basically, if you see the Postgres is widely implementing in the market, what is driving it to implement the PostgreSQL? So that is what you're going to discuss here. And database limits, what are the limits? So it is open source. So does it have any limits, and what kind of limitations we have on the product we're going to discuss here. And database common name, what kind of naming conventions we use in Postgres when we compare to other RDBMS systems. We're going to talk about a little on that. And the need of learn PostgreSQL. What is the need? Why the PostgreSQL is widely implementing? The reasons I'll explain. Then the need of learning PostgreSQL you'll understand. Okay. Then what are the content we are going to cover, and how we get the support for the open source technologies, who supports it, who developed the open source, how the journey happens for the open source technologies, all that we're going to discuss in detail. So let's start with the history. The agenda starts with the history. Let's talk about Postgres history, how it is started, who started, how it is evolved, and how it is growing nowadays, all that. Okay. Someone not on mute, please mute. Yeah. So let's understand, guys. I want to just touch base the history first, then I'll talk about many other things. Don't worry. First, understand the history, because before learning any product, knowing the history is equally good and important as well. Okay. For that reason, I want to cover the history. Then I'll move the rest of the topics. I'll talk about rest of the topics. So Postgres initially started with a name called Ingress. In fact, okay, the initial name of Postgres in the beginning days, it is a name called Ingress. In fact, so this is developed by two people. Okay, Michael Stonebreaker. There are two people who developed this product, and Eugene Wang. These are the two people started the Postgres development in the beginning days. This is developed for different purpose, not for the RDBMS, in fact. So the ingress stands for, okay, interactive. I'll explain a few things here. Interactive graphical retrieval system. In fact, graphical retrieval system. So this is basically designed in the initial days for the tracking the geolocations, in fact, geographic locations for military purpose, not for the RDBMS purpose. For military purpose, this product got built initial days, and at the time of development of Ingress, there is a product called System R. System R is one product developed by IBM, in fact, in the year 1973. Okay, 1973, there is a product called System R developed by the IBM. It's a relational database management system released in this year. But initially, government, this is the money who funded for developing this product is government to build this product to track the geographic location of the locations, geo coordinates and all that. In fact, the initially the Ingress, the Postgres old name is Ingress. The Ingress initially proposed for the defense system, not for the RDBMS system. It is a geographic data system. Initially, that's where they funded the money, and that's where the project was started. But in the 1973, there is a IBM company released a relational database system, System R. This actually motivated these two guys to convert the ingress into RDBMS system. So they read these white papers, they got inspired, they proposed they wanted to build this system as an RDBM system. They got the approval. Then they started working, developing the Ingress as a relational database system. Okay, but initially it is not. It was developed. It was like first initially proposed for different purpose, but later on it converted into RDBM system by the inspiration of system R, our relational database system. So they started this in the 1973 to 1985. Okay, yeah, they took roughly, if you look at here, 12 years of development. They have developed this code. 12 years of development. So they developed the Ingress full-fledged product in 12 years. In fact, it took 12 years. But in meanwhile, there are a lot of twists and turns happen. I'll explain. Full-fledged product. So in the meantime, when the Ingress is getting developed, a a project manager in the in the project of within the Ingress product, a project manager took the code from the Ingress and he separated, like he built a separate product called Sybase. He built a separate product called Sybase. So he took this team of people from the Ingress product and he took the code, source code, and he started developing the Sybase. In the year, I'm trying to talk about, it started in the year 73 to 1985, right? So this is 1985. Okay. So in the 1985, 1980s, in the beginning days of 1980s, a project manager from the Ingress took the code and developed the Sybase. And Sybase actually started growing better than the Ingress. In the initial days, Ingress development got slowed down, in fact. Okay. The Ingress development got slowed down, and the Sybase, they developed very well. And after that, Sybase is given to Microsoft also for the further development and testing, making the product robust and everything. Microsoft took this code, Sybase code, for testing, like making the product better and stable, all that. But Microsoft, once they understand the code, they purchase the code from the Sybase, and then they started their own journey. Okay, so Ingress, from the Ingress, Postgres got divided. For one of the project manager came out of the Ingress and he developed the Sybase and he popularized the product between the 1980 to 1990. This is a window where the Sybase got actually good market in between these years. At that time, Sybase has given to this product to Microsoft to make it more robust, and Microsoft understood the product. They purchased the Sybase code rights and they developed the product. They are running the MS SQL server now, and it is much better than the Sybase at the moment. Sybase is almost out of the market. This is one side of the journey. Other side of the journey, when the Sybase, in the 1980s, when the Sybase, someone took the code and they developed the product and they are outshining it. Stonebreaker left the Ingress, in fact. Okay. Stonebreaker left the Ingress. He wanted to develop his own product, just like Sybase, but it did not work for him. The Stonebreaker wanted to build the same product like Sybase separately, leaving the Ingress, but he could not make the product and he failed. That's where he joined again Ingress. After he joined the Ingress, I'm talking about, like in the year 1985. 80, he left in the 1982, in fact, when the product got full-fledged. And in these 3 years, 1982, 1985, he left and he tried to build a new product, but it didn't work for him, to Michael Stonebreaker. Then he joined back this Ingress. When he joined back, he started building the product with a better, what it was before. Now he's trying to make the product better. So when he joined back, it became a Postgres. Post, see, pre and post. Pre means in, here in was taken here from here, then they made it Postgres, in fact. Okay, They made it Postgres. So post, why they made it post? In fact, when the Michael Stonebreaker joined the company back, he started making the product, more robust with the existing people, with the help of existing engineers. Then he started, like it's a post, before and after kind of Postgres. This is how the naming convention given to the Postgres. Someone, please mute and can you guys see my screen well? Do you guys have any issues? My screen is visible to all of you, right? Yes, no? Quickly
Yes.
confirm.
Yes,
Okay.
yes. We are able to see.
Right. So here, in the 1990, in the 1990 year, after Stonebreaker joined the Ingress, they released the first version 1.0 in the 1999, and the 1990, so 1989. Was the story of 1989. In the 1990, they have released the 2.0, and in the 91, they have released the 3.0, and 1994 they released the 4.4.5 version something. So during this window, they had a programming language called QL. Okay, QUEL programming language with the Ingress product. With the Ingress product, there is a programming language called QL. It's not efficient. It's not user friendly. It is very tough to understand. The QL programming language is a one which is a big roadblocker to not to implement in the market. People did not adopt this product because it's very tough to understand. It's not that easy. So the programming language is not good. So they integrated the SQL with the Ingress, okay, the Postgres. Then it became the PostgreSQL. In the year 1995, the Postgres became the Postgres. After Stonebreaker rejoined, Ingress became Postgres. After they integrated SQL in the year 1995, it became the PostgreSQL. So that's how the Postgres got evolved. Uh, okay, PostgreSQL. So let me quickly recap. So in the initial days, the Ingress was originally not for the RDBM system. It was funded by the government body to develop the product as a geographic tracker. But when IBM released System R as a relational database system, these two people got inspired by this release, and they proposed they wanted to make the Ingress as a RDBM system. They got the approval. They started working on it. Okay, then in the middle of the development of the Ingress product, one project manager took the Ingress product. Uh, Source code, and he built a Sybase to Microsoft. We know that how the Microsoft journey is going on in the market. If you look at the Ingress side, when Stonebreaker left, he wanted to build his own product between 1982 1985, but it did not work for him. When he joined back the Ingress became the Postgres. They named it post development. Whatever we had it before, they are going to make it enhanced product. So that's where the Ingress got renamed to Postgres. Postgres again is integrated with the QL programming language, which is not efficient at all. It's not a good programming language. It's not efficient. It's not user interactive. It's tough to adapt to the people adopted by the people. That's why the product is not outchained between 1989, 90, 91, 92, 93. So if you see different version they released, but it did not outchain. So they integrated the SQL programming language with the Postgres. Then it became the PostgreSQL in the year 1995. Okay, in the 1996, they made it official. The actual Postgres got officially, given to the market in the year 1996. In this year, they developed this Postgres.org site. This site is actually download Postgres if you go to. This is a site. See, postgres.org. This site got developed in the year 1996. In fact, they made the code available to anyone. Anyone can develop. Anyone can build their own product with the source code. Source code is available for everyone in the market now, still now. You can take the source code, you can develop your own version of Postgres. Everybody doing it. If you go to the cloud, every cloud, distributor have their own Postgres version now. Azure has its own version, AWS has its own version. So they took the source code, they are developed their own products in the market. So since 1996, the Postgres still open source. If it is open source, who developing it? How the development of the product is getting driven, and who are supporting the product if there is any bugs? Okay, so all that we'll slowly understand by the end of the class. I'll discuss about it. But this is how the Postgres evolved. It started with Ingress and then PostgreSQL, and from these multiple products also evolved, in fact, right? This is about little information about the history of Postgres. So it is evolved from Ingress product from the University of Barclays. In fact, 1982, Michael Stonebreaker left the Postgres and joined in 1985, and it then became the Postgres. And Postgres again released 1.0 version, 2.0 version, 3.0 version. It did not work. In fact, in the 1995 they integrated the SQL, then became the PostgreSQL. So in the year 1996 they officially released the Postgres version, and they built postgres.org website where the product is made available to everyone at free of cost. They can download, they can develop their own distributions if they want, if they can understand the code, if they want to add their own functionalities, their own enhancement, they can do it. They can build. You and me also can do a different version of Postgres, distribution of Postgres, if you really understand the Postgres open source code. Okay, right. This is about a little introduction, guys. This is about history of Postgres, how the Postgres evolved and how it is named like Postgres, in fact. Okay, right. So why Postgres? Postgres is open source. That's a big selling point in the market. So everybody is doing, to earn the money from the market. When they are doing the business, they are thinking about where they can save the money in terms of operational cost, in terms of software licensing cost, in terms of anything. So wherever people can save the money, that's where the people are adopting nowadays. Everybody are smart. So in that space, Postgres is one of the database system which is not charge you anything. You can add all the you can get the all licensed version features, in fact, even better features. I'll talk about what Postgres give you better features than the licensed versions. We'll talk about in the next slide. Anyway, so the Postgres, the old most advanced open source database system, is getting widely implemented day by day in the market. So it is opening the a lot of opportunities. When it is getting implemented, more implementation, more jobs, obviously, right? Designed for flexibility and customizations. Anybody can, add up their own customizations if they know how to add modify the code. It is not something rigid. You can build your own extensions, you can build your own enhancement if you really want on top of the code, as according to the need. If you go to Zerodha in India, the the trading platform, biggest trading platform in India, Zerodha, they developed their own version of Postgres. Entire Zerodha trading platform running on the Postgres itself. They developed their on their own. They're using their own version of Postgres. In fact, if you talk about many people are actually converting to Postgres also in the market because of the open source in nature. You don't have to pay money at all. Okay, that's how the Postgres is growing drastically in the market nowadays. It's a ANSI compliant, means it is compatible with every other product that is available in the market. It's not just a, one side of product you are developing and it is not compatible with the rest of the products. You can migrate to any product, or you can migrate to any product to Postgres also. So that's what ANSI is, a one body which will certify a product. Is it compatible with the rest of the products that are available or not? Then only it will become a ANSI compliant product. Okay, they will check that. So yes, Postgres is compatible with every other product that is available. You can migrate to other products, from other products to Postgres. It is possible, right? So actively developed more than 20 years. If you look at 1990s to right now, 35 years if you count, since 1990 to 25, We are into 20 35 years of development, working on the product. They are keep releasing the new versions every year. Who develop, in fact? Why, how they are able to release every new version? I'm going to talk about entire history. Don't worry, in the further slides we're going to talk about. Right. This is one of the important slide you need to understand here. See, hybrid database in entire market, Postgres is only one product which supports the NoSQL and SQL together. No other product in the RDBMS system will support NoSQL as well as, you know SQL part. What exactly NoSQL, what exactly the SQL side? Let's give an understanding. I'll so try to follow this. I'm not finishing anything today. We're going to talk a lot on this. We have dedicated modules how NoSQL can be supported by the Postgres. I'm supporting my project, in fact, how SQL can support both the sides. This is a Postgres server. Okay, this is a Mongo server, this is a Postgres server. So, and let's go to the Postgres server quickly here. So if I go to and check the databases, these are the databases I have it, and I quickly create one database. Create database. I want to show that how Postgres is a hybrid model, how it supports the NoSQL, how it supports the RDBMS, both the sides. Let's talk about the NoSQL side quickly. This is a Mongo server. Where I am right now, I am in the Mongo server. So show DBs. I have these databases. I want to create a new database. Okay, class 100. It's a dynamic, fully dynamic. You don't have to create any object. NoSQL products are dynamic schema. You don't have to do anything. So I'm just using the database class 100. It will create on the fly, everything on the fly. I'm trying to load the data into student table. Student, see, database just got created. There is nothing in it. Show collections. There is nothing. Okay, there is no collections at all at the moment. So I'm trying to load the data db.student. It will create everything on the fly. The NoSQL, every NoSQL product is like that. So I'm just trying to load some data. S number one is the first record. Just a minute. I just want to show that how NoSQL works, then how SQL works. The difference you need to understand to make how it is a hybrid product kind of, right? So S name maybe Kumar, second record, third record. Every record can have any shape, n number of fields. There is no definition of fields that you have to do. Everything can have a different set of data in the NoSQL technology. Just try to have an idea. That's it. It's not something you definitely need to know. But what is NoSQL? So NoSQL is the one thing where your data, every row can have a different data, in fact. Okay, first record has one field, second record has two fields, S number, S name, third record has the three fields, fourth record has the four fields. Within one table, it's equivalent to one table. Every row can have its own shape. There is no restriction how data need to come into the system. It supports the structured, semi-structured, unstructured, any kind of data. Any kind of data you feed into this system, it will take automatically. Fields will be created automatically, data will be taken automatically, no rejection at all. Whatever the format of data, it doesn't matter. That's how the NoSQL really works. It just accepts the data the way you are loading into it. It doesn't matter how you really keep the data. Okay. So now, if you come back to the Postgres, this is RDBM system, obviously. So let's create here also a database, or else let's check what tables I have. These are the two tables I have it as of now. I'm going to create a table. Create, let's drop the table if I have it any. Employee, I'm dropping it. Drop table, other table also. Quickly, I just want to how these two are different, in fact. Teacher, right? Right. So I'm going to create table student. It is a RDBMS SQL format kind of table. NoSQL I'll create here, and we load the data, we read the data, how it look like, we'll see. Just I want to convey that it supports both the products like NoSQL, SQL. Which one? The Postgres. There's only one product right now in the market which supports both, in fact. Now I created a table with the three columns. Describe the table. Okay, describe the student table. You have three columns: S number, S name, S address. Okay, exactly. You have three columns. Now I'm going to insert some data into it. Insert into student values. So example, I'm loading some data just for the use case here. So it will accept the data as long as you are able to fit the data what you defined. It will accept it, this data. But if I make one more extra column, maybe phone number something, which I did not define here, I did not define, it is throwing the error. Insert has more expressions than the target columns. All RDBMS are rigid in the form of structure. You can't load the data unless you define the structure. You must define the structure, then you load the data. That's what RDBMS format. But Postgres supports the NoSQL also inside in it. Let's create the table, another table, teacher. Okay, and here number integer, team, varchar 100. Address I'm going to define as a different field. T address. Okay, JSON. I'm going to define this as a JSON. Okay. So what is JSON, that will be explained, and I'm working on the MongoDB more than the Postgres. I would say that I have a close to 9+ experience on the MongoDB, and I do train on the MongoDB also. I work in and out of the Mongo. What is JSON? JSON format. Okay, it's a Java notation kind of. This field JSON B supports the NoSQL. This is a term you have to use it as a data type when you're defining a field. So if I create this table, if I go and check the table structure, it will show this as a JSON B, the data type side. Now if I'm loading the data into this, insert into table teacher values. So I'm loading the data here. One example, Praveen. And third field, I define it as a JSON. Here, I can define this, I can load the data here as a JSON. Okay. Example, you have a street. I want to define the address. Okay. Just a street here, or you colony. Okay. First for address, I'm giving only street, not more than that. Second, I'll give you more information. So try to follow. It is natively supporting the NoSQL data. That's what I want to really prove it here. Okay. Nothing else. So here street locality example. Okay. So whatever it is in NTR Nagar, some whatever it is. So here locality is added extra as an extra field. So you can add n number of fields. It doesn't matter when it is a NoSQL. Let's make this as a third record. This one. So here I'll add the extra part again. Yeah, city. Okay, what went wrong here? City should have the quotation. Yes. Don't worry about this. I have a separate discussion on this. Just try to follow this. That's it. So if I read the data, how it look like? It's a Postgres, table. I mean, a table in the Postgres supporting the NoSQL data in one of the field. You can see the first field here. It has one field. It has a multiple fields. It is even have a more fields. No definition. No number of fields. First two are restricted. First two are restricted because they are the SQL standards. If you go to here, these two are the integer, this is a character type. This one is only one field. You can have n number of fields inside in it. So if when I'm reading the data, I wanted to read this data in the RDBMS format. The NoSQL data, this is a NoSQL data which is integrated with RDBMS. This RDBMS data, this is NoSQL data together. That's called, it's a hybrid database. No other product in this market as of now supporting both the technologies together. Only the Postgres. This is also one good selling point for the Postgres now. So if I want to read this data as an RDBMS, okay. So how do I read it? So example, just for the use case again, T number, T name. Uh, when you have to call this data, you have to call this way. Anyway, I'll talk about this in the module once because I'm supporting this data in my project. There are certain requirements. We have to have the SQL data, no SQL data within the Postgres, and we are supporting it. So I'm going to talk about that a little to make you for your understanding sake. Street here. If I read this data, it will load in the RDBMS format, not in the JSON format. From teacher, if I read this data, you can see that. You can see the no SQL data is reading in the format of SQL data. You can see that. If I want to read the other fields as well, I have to just add it. So T address, what is other field called T name? No, it is a street and locality, next locality. Here, you have the street, you have the locality, then you have the, yeah, locality, let's keep it. I'm converting the NoSQL data into SQL type. Okay, you can see that. All the data converted back to the SQL format from the NoSQL, in fact. So Postgres is the only one technology which supports the hybrid model in the market. This is also one good feature. Though it is open source, it is giving extra benefit, right? So it is outselling because of this. Also, one of the reason why the Postgres is getting built in the market, because some cases they need such features within the Postgres. One is a skill set, another is a no skill set. Both together is supported by the product. So this is a one good reason, one of the good reason Postgres is getting implemented in the market. Okay, only one RDBMS database system which supports the SQL and NoSQL together in the market as of now. Absolutely. Configurations are simple and easy. Basically, it's like a NoSQL. NoSQL is a binary based products. All are. Postgres also binary based. Almost all Unix flavors are binary based products. Almost all. Without, you will have a binary based installations and you will have the repo based installations. Okay, manually you can install using the RPMs. There are many different installation methods we're going to go through anyway in our course. I'm going to talk about that. In terms of configurations, Postgres is dead easy to configure any technology. It's not tough. I'm going to do everything in respective modules. I'll talk about the modules at the end. What kind of modules, what kind of content we're going to cover in this course. I'm going to talk about that. But Postgres configurations are simple, not at all tough. But where the challenge comes when you have to troubleshoot. When you troubleshoot well, when you know the product background well, background in the sense architecture well, we're going to talk about the architecture only after this. Okay, so configuration wise Postgres is very easy. That is another selling point. Portable ANSI, see, I just said like it is a ANSI certified product which is distributed. This Postgres database system is compatible with every other product in the market. It's not just isolated product where it does not accept the format of other products. It accepts, and also it can be migrated to other products. That's what the ANSI standard mean. It is an ANSI certified product, means it is compatible with every other product that is available in the market. So when it is available, you can migrate it to Postgres, right? When it is open source. See, if you look at in the market nowadays, you're seeing in your companies also, even we are in our companies also, things are migrating to Postgres. If you talk about AWS, they shut down the last Oracle server. They used to be on the Oracle in the beginning days because the criticality of the product. Amazon entirely shut down entire Oracle stack and they are running entirely on the Postgres. Entirely, entire Amazon products are running on the Postgres itself. They are not running on any licensed based RDBMS as of now. So see that How they are able to migrate? Because it's ANSI compliant and it runs on any platform. It's not compatible, it is not tightly coupled with any operating system. It is available in whatever the operating system is available in the market. It is available in all operating systems. If you talk about SQL Server, most of the market, 99% still, it is just running on the Windows. Till 2017, the SQL Server is tightly coupled with the Windows only. You can't install the SQL Server on Linux flavors or any other flavor except Windows till SQL Server 2016. In the 2017, SQL Server 2017, they made it available on the Linux flavors, but still no one is implemented because the market is grown like that. Technicians, there are no technician availability to support on the Linux platform, the SQL Server. So there is no problem with the Postgres. People are available, they can support. It's a code based product. The OS also code based. So 95% of the market runs the Postgres and the Unix flavor only, not on the Windows, because of the performance gains. We get the good performance, good control, more security when we run on the Linux flavors. That's why I entire course our course runs on the Unix flavor only, the Postgres discussions. Right, acid compliant like atomicity, consistency, isolation, durability, all are supported by this product anyway. Atomicity talks about what? Either you complete or roll back completely. It should not be left in the off done state. Okay, the status of the transaction should be, either, the same thing like consistency of the data should be maintained. Isolation is something. One transaction should not interfere with the other transaction when it is happening. It should be isolated so not to have the data discrepancy. Durability, even system get rebooted, it should recover on its own. Once committed means committed. It should be recorded in the log file. Even it is not committed, it will be roll forward, roll backward based on the transaction status when the system get rebooted. So Postgres will follow all these, compliances. In fact, supports the begin, commit, rollback. If you want to commit the transaction after it is done, or you want to roll back, you have the control. You can control the transaction as needed. If you begin a transaction, if it failed in between, you roll back. If it goes till the end of the transaction, then you commit it. So that way you can control the program. Okay. So val files is something, is a log file for the PostgreSQL Server. If you are doing any transaction, which will record in the val file. How you recover the data using the val file? Point in time recovery is how you do it. We have a clear cut scenario, point in time recovery scenario. Point in time recovery is not straightforward in Postgres like other products. You have to recover in a different system, not in the same system. We always recover the point in time recoveries in another system, and then we will fill that whatever the data was deleted accidentally. When we do the point in time recoveries, basically when there is a corruption or someone is accidentally deleted the data, you recover in a different system and fill the data in the live. In fact, how it happens, what is the process, the entire documentation I built, we will talk about that as a separate story. This is one of the biggest good thing in the Postgres, I would say. The biggest, along with the open source, along with the hybrid, I would say that MVC is one of the biggest selling point again to the Postgres. This is what exactly says: no writes will block the no reads will block the writes by default. You do irrespective of number of transactions. No writes will block the reads. No reads will block the writes. Which mean in the real world, the biggest performance culprits are always the reads. Reads are the biggest, performance culprits. Reads never creates any issues in the Postgres for the write operations. Both are completely isolated. How it is possible? It is possible. There is a background thing will happen. Every transaction will take its own snapshot of the data when it is modifies. When you read, it won't create a snapshot. When you modify transaction will take its snapshot and do the modification, apply the base. Old records still available in the system. New records will modify the existing, but old record version will be still be maintained because reads are reading it. We will see that how in detail. I'm going to show that how system can manage the reads right together without overlapping the lock. You don't have to go with the no lock concept here. By default, Postgres supports in by default nature reads writes in parallel. They can run without any locking. How it is really possible? I'm going to show in practical. how background data will support these operations. I'm going to show that. See, guys, I keep my trainings very outstanding with any other trainer, because I I try to make you understand right from the background to the entire configuration side, the troubleshooting side. I'll create the scenarios, I'll create, how you find it, how you fix it, how you follow up and all that. It's not about what is my trainings never be what is what, basically. So I'm going to cover everything how it is going to works. Okay, here. This is a very important feature of Postgres compared to other products. It supports the table partitioning like any other product. We have all RDBMS supports. This also supports with a better control than other products. I would say that Postgres does better control on the partitioning than other products. How it is really, we're going to talk about. Table space is like, a table space is like you can create a file system. Example, I'm running the Postgres here. Okay. Now I have only one file system. If I load all my data here, it will fill and IO will choke. If you are loading all your data, hammering one file system for reads, writes, definitely IO will saturate, right? So to not to have that, we can have our own table space, different file system, different storages, in fact, altogether. I can create one database, in each database into different table space. Example, A database, this is a B database, the C database, assume a case. I can create this in this one, I can create this in this one, I can create this is, but application side, you hit the database logically, but physically database are segregated into different storage system. In fact, even in if your database, one of the database is growing very badly, tables are too big, assume a case. Come on, just a minute. If you can do lot many things with the table space. I'm going to discuss a lot on the table space, table partitioning. These are all very important towards the performance tuning. So how they are going to improve the performance? So in reality, I'm going to show.
Oh,
Yeah, go ahead.
yeah. Hi, Ravi. Sorry to interrupt you.
Yeah,
So
go ahead,
if
go ahead.
yeah. Sorry, I had a doubt over here. So you're
Hmm,
telling like it's a hybrid database. It supports like it will act like a RDMS and NoSQL. So
hmm.
how will be if you are reading while reading the data consistency should be there, and you are inserting without a row in in a particular table. So
Hmm.
in that case, that particular column will be a null value or still is an empty value.
No, no, it takes a copy of it into another copy. It makes a copy of the data, then it does the actual modifications. It won't touch the existing. Every modification will take the copy of the row, then it does the modification on the copied row, then it will apply to the base, and uh, the copied row will be maintained as separate copy only. Old copy will remain as an old copy only. It will maintain the row versions. Every modification will create a new version. We'll see that. I want to show that how it builds the row versions, how you manage the, if it is building the too many row versions. If I'm modifying, example, if I'm modifying 3 records, I'm modifying, it will become 6 records. If I modify 3 again, 9 records. These 3 records can become 100 records if you are keep modifying it. It is possible
Correct.
because it's maintaining the row versions. How you manage that side, we have a discussion. Don't worry.
Okay. Why? Because I have seen this kind of things in my environment. So
Mm,
where they'll be modifying lot of, and it is data is keep on growing up. So
mm,
I like based on your right your right now your discussion. So
mm.
I'll come to know this is what happening. So why do we call this as a RDBMS? I think it will play as a
No,
no
no,
no signal.
no, 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 no. It's a maintaining the row version. You can, it is RDBMS as well as NoSQL together in this format. As of now, what we are talking about, when it comes to the row versioning, they are letting us, two operations run together without any overlapping of lock, which is very good that they are giving the concurrency. But the maintenance side, automatic maintenance is there, manual maintenance is there. How you monitor that fragmentation, how you claim the free space, how you clean the unnecessary space, we will talk about that. Don't worry about that side. We have a lot of discussion in that area, because that's where the Postgres we need to understand. If you don't understand that area, you can't be a Postgres DBA. So how Postgres runs with MVC is the biggest point in the Postgres. I'm going to spend real good time on this area, because this is where you have to explore a lot on the Postgres. A single table have 100 records can become 1000 records, 2000 records also. You are keeping on updating it. You are not inserting, but still you are updating it. It can grow a table size without new data. It is possible in Postgres. Then when it is growing, how you control it is a big topic we have. Okay,
Okay.
I'll explain
Okay.
that. Don't worry. In detail, not just what is what. In detail with the background data, how it loads within the background, row by row internally within the data pages. That also we can read, and I'll explain that. I'll
For
make you
this
understand
particular
for sure.
for this particular multiple concurrence word, right? So
Hmm.
whenever we are reading, it will see, sometimes we'll be seeing the logs or blockings in these sessions.
Hmm.
So but you are telling like it will completely take a snapshot of that and read
Hmm.
the data. So that
Hmm.
will while reading the data, see, when after reading one more time, it will
So
show a
reads will
different.
take the snapshot. Reads will remain as it is, the existing data. If I modify, then only it will take the copy. That new copy will be written. New copy will be made available when the committed. New data you will read it. Old data it will become a dead data. When you are reading this one example, you are reading these two columns. Okay, I am modifying these two columns also. When that update is going on, I can still read the old data because update is not committed. Once it is committed, you read the new data, not old data. Old data will be dead data. It is still there, but it's dead.
Yeah, I
When
think if this follows, right, we cannot have the consistent data, right? On a live data, if somebody is relieving the seeing the data for a reporting purpose, if our timing, if you see that data
mm,
will be the consistent while
no,
reporting the
it
data.
is consistent. I'll explain. Okay, don't worry that in that module, but still I quickly explain. I have one, two, three records. Okay, one, two, three
Okay.
records. I'm reading these two example. I'm
Mhm.
modifying at the same time. If I'm
Okay.
reading this, I'm getting the actual data. Modification is going on till it is finished. The modification. You don't read the data. You'll read the only previous data. When it is committed, you don't read this data anymore. Only new data you'll read it. When it is committed, you always be consistent. You don't lose a consistency here at all because the
Okay.
transaction is not committed yet. When it is committed, committed data only read will go to committed data because that data is available for the read, not the old one. That will become a dead once it is committed. You never see the inconsistent data. It is consistent data always. We'll talk about that. Don't worry. The life cycle of the data is very important topic. We are in the
Yeah.
demo itself. I'll justify entire thing end to end life cycle of that data in the maintenance discussion. We have very lengthy discussion there. I'll explain. I'll show you how it is consistent. In reality, how background support us to do all this. I'm going to show background page. It is in the storage as a page. I'll read the page. I'll show you the slot by slot data. How the updates will run when the read is going on. Once the update is done, what happens to the old data? All that we will see, visualize it. Don't worry. Everything I'll make you. It's my guarantee that you will walk away with the best knowledge. I'll keep my training absolutely outstanding. You feel it by the end of it. I'm not exaggerating anyway. I'm working since very long. I know this product in and out. Don't worry. So here, guys, one database, one table is growing bigger. Assume a case, one table be I can create in this table space in a different file system. One table can be here. A database can be distributed. A table can be distributed. Okay, everything can be done to scale with the data, amount of data. If data is growing too big, we can't keep everything into one file system. We have to distribute to different file systems so that database will scale with the large growing tables. One table can go to one table space only. You can't go back to multiple, but you can partition the table. The partitioning can go to multiple table spaces. That level also I'll discuss. Partitioning with the different table space also I'll discuss. Don't worry, we going to discuss very in detail. Performance side I'll focus a lot. Performance especially, I focus a lot of topics and in detail, because knowing the product is one side, doing making the product better with the performance side is another thing. Any product. So we'll focus a lot on that area. Don't worry. So right, this is about the table spaces and secure. See, Postgres, MySQL, or any other product in the Linux flavor. This is like uh, Postgres gives you better security than other products. I would say that it has the a file where you look at the file, your IP is authorized or not, then it will go to the product for the authentication. It's a kind of another firewall, OS level firewall, product user, user password, then permissions. Many layers will pass through a user before doing the action. So OS-based authentication, there is a file to authorize a user first, whether user is coming from an IP, that IP is allowed to connect or not in the Postgres. There is a file within the Postgres. You have to make that IP authorized within this file. Then only it can make a connection. You can control every traffic using that file. It's a one entire firewall for Postgres before you making a connection. For SQL Server, you don't have that. Product does not validate any kind of incoming traffic. If it is allowed at the host level, you're allowed to SQL Server straight away. It's licensed and you're paying too much of money. But the Postgres having a file where it will filter your traffic, whether you're allowed or not, it will verify, then it will take the authentication, then authorization. There are multiple layers will work for the system. Very controlled access, in fact, compared to licensed. Yes, it is giving, though it is open source. You can give the row level permissions, you can do the auditing, and you can easily monitor the slow running transactions, everything. In fact, you can encrypt the incoming traffic, like in SSL encryptions you can implement in the Postgres, everything it supports. Though it is open source, it's not having some features which you are lagging it still have every feature that you have in the licensed versions, in fact. And recoverability and availability, it has the automatic failover, you have the asynchronous replication, synchronous replication, logical replication, like object level replication, lock shipping, only ship the locks and update. Okay, you have cascading replication. Like I'm going to discuss everything in practical. I'm not just saying it. So I have a server, I have a B server, I have C server. First I'll do the replication from A to B, and from here to here. This is called cascading replication. Okay, cascading replication, one to other. You are not putting the load here, you are putting the load here to move the data here. As advantage, disadvantage also. Every technology, every implement, synchronous, asynchronous, cascading replication, lock shipping, you have logical replication, automatic failovers, everything will be covered in the replication modules, streaming replication modules. Everything will be covered: synchronous, asynchronous, cascading, lock shipping, automatic failover, logical, which means object level replication. We have a very good discussion on the high availability. In real, I'll configure it. I'm going to show every issue that happens in that technology also, not just configuration. Okay. Replication slots is one thing which is available with the logical replication. Without transferring the data, it cannot be deleted in the val files. So this will make sure that your data never get deleted unless it is transferred to the secondary servers. We'll talk about that feature anyway, one by one. So PG based backup, you can take the server, entire server physical backup without locking anything. It's a very good feature. You can take the file system backup without locking the file system, though the server is running. So one good feature, I would say, that in Postgres. In RDBMS, I mean other licensed RDBMS is also, like you have the online anyway. It also supports in SQL Server, you don't have it. You can't take the physical file system backup when the system is running, it will be locked completely. So it is supporting it. Point in time recoveries are also equally like licensed versions. You absolutely can recover whatever the point you want. So Postgres here is open source, doesn't mean that it is not supporting certain features. It is supporting almost all the features what licensed is supporting. Why it won't replace them? Right? Support is a big reason. We'll talk about that at the end. Advanced things here: supports triggers, functions, any programs, all programming languages are supported by the Postgres, what they can develop from the front end side. That's a good thing. PG upgrade, if you want to upgrade, one binary will upgrade your entire server. You can check the compatibility, you can upgrade the server using one binary. One single binary does everything for you. That's a one good thing for us. This single binary itself will tell you whether you are upgrading lower to higher, one version ahead, is compatible or not. We can check first. If it is not compatible, it is going to report what is not compatible. And you have to fix it, then you have to upgrade. How you run the compatibility check, how you upgrade, versions ahead, multiple versions, one version only it will support. If you want to go to multiple versions, you have to go through the backup restore side by side. There is no other way. So how this can be done? We going to go through the entire steps what we use in the real time. The entire process also I'll explain with the practical implementation. Okay. Unlogged tables. Unlogged tables means it will not record the transaction entry into the log file. It never make entry in the log file at all. In SQL Server or Oracle Server, you don't have this concept, I feel. Oracle, I'm not sure. SQL, we don't have it. I can create a table temporarily. I can turn the table temporarily, not to log anything. I do lots of data load, lots of modification. It never records in the log file at all. You lose the data if it is get crashed, but I can save the time. It will be so fast, and also it does not flood the storage. Unlocked tables, you can any table can be unlocked. You can become temporarily, and then after the activity is over, you can convert into logged. All operations will log as usual. So you have this real good feature. It's a plug and play kind of. Any live table you can make it unlogged, do the bulk operation and make it logged. During that bulk operation, whatever it is done, that cannot be have a recovery. That's one caveat we have. We need to understand. But it is a good feature. Certain in certain use cases, it will help you a lot. So good and bad side we have to see. You have to weigh which is good, which is bad at that moment. Nothing is good, nothing is bad, but it's situational. At that moment, the benefit side you have to look at. The more benefit side. Materialized views are very important in the performance tuning, in fact. So what exactly materialized views is, I have a 10 tables, assume a case, 10 tables. These 10 tables, I am writing a one complex query to generate one output, one single output. That output I'll create as a materialized view. Every day I'll run the materialized view refresh. I read the data from here. So no need to run the logic. Logic is executed, loaded the data in the materialized view. I generate the report from here. It's a ready-made data. It's physical data. Your logic will execute and create one more table with that output of your data in the night. And
This
the next
will
day,
create a separate extra space, right? Express
yes,
it will.
yes, yes, it is. It is. What is the advantage is, you're running the this logic in the night and loading the data into the materialized views data. It's like a physical table. View is a physical table. You generate the report here. You are doing that nightly work and giving the data business with so fast, without any the calculations. You are not doing anything. It's just straightforward data, the format the client wants. It will improve your performance 100 times, in fact. It's a very good feature we have in Postgres, materialized views. I'll show this how it works. We have a topic on this, how the performance gain you can get with the materialized views. We can create the indexing also. Materialized views are logically, you know, logical pointer, but keeping the physical data, and that also you can create the indexes to improve it. So there are many layers we can do the performance anyway. All that is a part of our discussions. Nested transactions. Here, example, understand this. Let me make one more notepad. These are all highlights, guys. I'm not finishing anything today. I'm just trying to tell you these are all there. Okay. So example, I'm running transaction A here. Okay. Transaction B. I'll whatever the transaction A I did, I'll save it. Okay. I'll save it here. If transaction B, if transaction B successful, okay, then it should roll back everything. It should go back to the A and do the transaction. I mean, it should complete A transaction, not B. So within the one transaction, basically what is ACID says, ACID property says basically, either everything should be completed or everything should be rolled back. We can break that using the save points. I have A transaction, B transaction. I'm saving it. If B is not, see, A is doing one job, B is doing one other job, but this B is dependent on A. If B is failed, it should roll back to A, up to A, and A should be committed. I'm at least 50% my job is actually committed, 50% is failed. It is possible with the save points. I'll show that if it works. It's a real good feature. I'm not failing. I have 100 100 logics within one code. I wanted few transactions within the code, within the batch should be committed because they are not dependent. I don't want to roll back this one also. I don't want to roll back this. I want to roll back this one only. Because this I need anyway. I don't have any dependence on B to roll back. See, if this fails, I don't want to fail this. I can commit this. No dependency. In that case, save points will be used within the nested transactions. This is not there in all products. Again, there are certain.
Ravinder, sorry to disturb you.
What?
I have same scenario. Can you
Yeah.
repeat again? Like A and B, and what is the save points? It's
See, I have a example. Okay, I have a, I have a B. What I'm saying is I did a transaction on this, save this whatever the outcome of A. Okay, then go to B, do whatever you want to do here. If it's successful, commit this, commit this. Okay, I'm okay. If this fails, fail this, but I have saved what is outcome of this. This commit this one. So you are committed A, failed B. It is possible within a transaction using the save points. Okay, we will see
yeah.
that in
Thank
our
you.
we will see that in our class anyway. We have a discussion on that. Table inheritance, one table property you want to take it to another table, use the same, like logics with same data type, same kind of thing. You can take the inheritance, exact copy of that table inheritance. You can take it. It's hierarchical kind of thing. So that is also good feature what we have in the Postgres. I listed very few which are outstanding. There are many other we're going to talk about. These are all outstanding features what I just kept here. There are many good features that we need to go into discuss in our course anyway. Okay, what are the advantages if you talk about compared to MySQL, compared to Oracle, compared to Microsoft SQL, compared to MongoDB? How Postgres is better, in what way? So if you talk about MySQL, Postgres offers better compliance with the SQL standards, advanced indexing modules. It has many indexing types, in fact, richer data types. MySQL does not scale like Postgres. Scaling itself is a big problem with the MySQL compared to Postgres. It won't scale well with the huge data, in fact. Postgres can scale well, in fact. That's a MySQL problem. Oracle is a huge licensing cost. That itself is a big comparison. Postgres is absolutely free. No need to pay. We are running all our server with open source only. We are not paying single penny, in fact. Okay. So still we are operating huge infrastructure in the Postgres in our environment. So we are saving a lot of money, right? Obviously. Oracle is see, compared to Oracle, Postgres is free and open source with no licensing cost, first thing, while offering the comparable features that Oracle has. Compared to SQL, Postgres is a cross-platform, cost-effective, and supports more flexibility. If Postgres is open source, at the same time, it supports every platform that you have in the market. Unlike the SQL Server we mostly implement on the Windows flavors in the market, right? Because the people are not available to support technology-wise. So compared to MongoDB provides only unstructured data, structured data, but it's not ACID compliant. It is not ACID compliant, so you can't keep it for all use cases. So if you compare, there is some benefit is there when you use a Postgres. Just like a comparison, guys, nothing else. Right. This is a big point I need to talk about. What is open source first? Open to anyone, they can use it free of cost. When they are not getting the money, how do they develop? How the product is growing? Who is developing it? Who actually investing it? Is a big question, $1 million question it is, right? So basically, open source developed by the supporting people only who are supporting the product in the market. Okay, so let's go and explore that side. Download. If you go to the Postgres site here, okay, sometimes this is a buggy product. Sometimes, if you look at the packages Postgres, you have these many versions. In fact, you should not. We never go to the any version up to n-1. N-2 only will stay. That is our rule in our company. We have 16, we have 17th version. We don't have any server on 16 and 17. We have maximum 15 only because this is stable version, much stable version, absolutely trusted stable version. Nobody run the production on the N version in the Postgres. I'll upgrade to 7.2, 7.3. I'll show some issues also. in 7.3 issues. When you upgrade to N version, it can have a buggy things, because open source you can't escalate anyone. You're not paying anyone, you can't escalate anyone. Absolutely, it's a free. And who are making it free? How it is getting developed is a question all of you should have. So there are support people. See, there is a commercial support. If you go to the Postgre website, who are getting the benefit out of the, actually who are getting benefit is third party people. Who are third party people? Who are supporting the Postgres in the market. If you get a issue in the Postgres, your DBA can't resolve, then who will reach out? You will reach out third party support people who are supporting this Postgres. When you contact them, they are getting the money. When you use the product, basically when the product is keep developing, it is giving the good features, then only you'll grow your infrastructure further, you will implement the product. To have this, the third party support, if you go to commercial support, there are many companies in the market, continent wise. If I go to Asia, if you see, there is one company from Chinese, one company from, you can see that USA, Indonesia, one company from Indonesia, Singapore. And you see this one, second quadrant is a very famous company where they support open source EDB and everything. In fact, second quadrant is a one good third party company where they support the Postgres. In fact, as if you get any issue which you can't resolve by your DBAs or anything, they support. Not just second quadrant, it's one of the famous third party company which does the support for the Postgres as a third party. So when the Postgres is free, how it is developing? By the third party commercial support people only. No one is paying them. They are getting money through the support. If they want to come, the customer to come to for the support, they have to develop the product, keep developing the product. Then only people implement the product, then only they can get the support, right? They can come for support. If you look at commercial support, there are many companies are supporting this product as a third party, as open source. It is open source. If it is a buggy thing, you can't resolve yourself, you have to go to some third party only. They can only resolve it for you. You can't resolve yourself. So like that, if you go to Asia, there are many companies like this. If you look at, these people are contributing to develop this product year on year. They, if you take the Postgres evolution, let's explain that, then I'll come back to support. Understand this, very important. As I discussed in the history, what I said in the 1996 year is officially postgres.org is created and made available to the market in the 1996 year history. 1996.0 is released in the 1996 1997 closely. If you look at here, they keep developing every year they're releasing new things. They did not lose their confidence, and they are actually developing it, keep developing the product. When they're developing, that's where the implementation came into picture. They are looking at the gaps, they're filling the gaps, and what market needed, they're trying to adapt into the product. That's how the product is getting implemented. If you can't give what market wanted, slowly you will fade away. You can't be in the market and you can't be a competitor. So that's why every year a new version of Postgres will release. If you look at any version, see, let's see, Postgres 10th version released in 2017, 11 released in 2018, 12 released in 19, 13 released in 20. If you look at 17, 18, 19, every version, new version is released in each year. Without fail, they release it in the month of September or October. If you look at this one, this is a September, October, September, October. Every year, they release a new version. In 2025, they did not release. In the 2025, 18th version will come in the September or October as official new version. Every year they release a new version. Who are releasing, who are developing this product? If you look at who are developing, is the third party people who are supporting it. In fact, who are the contributor? If you look at here, if I go to support again, if I go to the community, okay, community, here there is a contributor list. You can see who are developing this product are the contributors. If you go to look at the contributors who are developing the product, let's look at them to understand that how the open source development can happen. If you look at here, see a contributor. This is from the EDB enterprise. This is from the Microsoft. This guy is from the different company, right? And this guy come from a different company. PGH, Cybertech, Microsoft, Postgres Professional, and Cybertech, Amazon Web Services. These are all people collaborating from different companies, and they are contributing to build the product. It's not one company. Whoever supporting this product, whoever like using this product a lot in the market, they have their one of the people dedicated for developing the Postgres server. If you see, there are hundreds of companies are sponsored their resources to develop the product. If you see, every person from different company, different region, different country, these people are coming together. They are developing the product. They are releasing it as a bundle, as a new version every year. If you look at again, if I go back to the home quickly, I'll go to downloads quickly again. If I go to the source code, if you see 16th in the 16 version within a year, 16.1, 16.2, 16.3, 4, 5, 6, 7, 8, almost every month they are releasing the new addition. How they are releasing it? Basically, these are all issues. They market came to them with the issues, some buggy things. Then they realized they are going to release it that as a new service pack. This is a major version. 16 is a major version. These are all minor versions. How you upgrade minor version, I'm going to talk about that. Okay, we have a real discussion how the entire steps model I'll explain. But if you look at how open source, though it is open source, they are keep releasing the patches as they are getting into the support. So if you go to here again, understand guys how open source operate. In fact, it's a big question for everyone. Who develop it, who really driving this product? Everybody driving, who are actually getting the money out of it. The biggest benefit makers from the product Postgres open source is cloud makers. If you talk about Google, AWS, Azure, they have their own Postgres version in the cloud, and they're selling on the platform, and the product is absolutely free, but they are making millions of dollars every year just through they're selling the product on the platform. They're charging a lot. Still people are taking it because everything end to end they're supporting it in the background. So they are the biggest benefits maker. In fact, they are generating huge revenue out of Postgres. If you see community means people who are contributor, you, me, and anyone is a community. If you go to community, okay, a mailing list. If you look at the mailing list, you can, if you don't have a like a paid support model, you can contact these people. Wait, community mailing list. It's not loading. Right. Description. Let me show. Yeah, mailing list here. Okay, I have to log in, it seems, to get that. Actually, you'll find the people who are supporting as a freelancing. You don't have to pay them. Still, they support you. Uh, Come on, you'll find it here. Community mailing list here. Right. If I click on this, right here, correct. So if you see this, guys, in the 2025, these many cases they resolved at free of cost. These are the community people who who supported without getting any money. So this is the issue. You can read through. This is the issue. Someone supported, someone said, someone resolved. There are many such issues you will find on the website. Whatever they supported, they'll post it here at free of cost. You can see here someone. You can see someone person .net. This is a person who contacted this guy from this guy. Okay, and that guy responded with the solution. The solutions are here. Come on, you can see entire the chart flow, entire solution given to each issue. It's up to you, like you want to explore, you can explore the issues that they have given in the each year. In the each year open source, I mean the people without getting any money, they're supporting the people in the market. They're giving the solutions. You can You can mail people actually. Contributor, no, just a minute. Mailing list also available. You can send a mail directly to the people. Come on, I'm not able to see them. You should see it. You can mail, but you can't demand them. You can request, I'm getting this issue, please help me to resolve it, kind of mailing list. I need to log in, I guess, to see that. Oh, come on. Sorry, someone saying something?
Yeah, can you hear me?
Very low, quite low. Your voice is quite low.
Do you know what's the difference between Enterprise Edition and then this one, the
I'll talk about
Postgre?
that. Yes,
Okay, good.
I'll talk about in few minutes about it.
Okay, no
After
problem.
after finishing this, I'll come
Sure.
back to the enterprise side quickly.
Thank you.
So, how actually the open source operates, that's what I'm trying to show that. If you are running open source, you get a buggy issue, you can't resolve yourself, the immediate solution for you, contact the commercial support instantly. If you go to commercial support, if you go to where you're really in that region, go to that region to get the online support for you. You contact them. You have everyone support numbers there. Okay, it's ad hoc basis anyway. They might charge you more, but you register with them, like you have to register with them, they will charge you less. So you are running a product, you buy the support yearly package. I'll raise a case to you, you support me in number of cases, maybe case to case. You have to register. When you register, you get the less cost for the support. When you go ad hoc basis, you get a issue, okay, something is burning, like you are actually going through some outage, no one is able to really resolve, you can contact, you call this guy, you explain them, they will come and they will take your remote control, they will resolve the issue, but they'll charge you more because it's ad hoc basis. So how commercial supports operates based on the subscription basis or ad hoc basis depends. If you are having a subscription, you get the less support cost. You're going the ad hoc basis because there is no guarantee you come again, right, for the support. Let's talk about this. So market implementation wise, market implementation wise, 80% of the market absolutely on the open source version of, which means open source means community version, community edition. Only 5%, I would say, that licensed in the market, entire market. Only 5% licensed market. So here, when it is a community edition, okay, these people run the entire project there with their own DBS. They won't contact any third parties. They directly operate the entire product end to end using their own DBA community within the company. 15%, roughly 15 here and there, okay, are supporting the going to third party for support. So if you see, licensed version only 5%, absolutely 5% market in the Postgres era. If you look at the market trend wise, who are using the licensed version? Only 5% of the market. 80% is absolutely open source community, and they are handled by their own DBS, no third party support as well. And they stay absolutely n minus 2. This is very important. N minus 2, mostly n minus 2. They wanted to use only stable version, absolutely. They don't go to n at all. N is only, you can't risk at all yourself. When you go to n, you definitely under risk. N means what? The latest version is n. What is latest? 17 here now, okay. Latest live version is 17. You can't go here, you can't go to here as well. N minus 2 is absolutely stable. You don't see the buggy product there for sure. So any people who are using with their own DBase, they stay at n minus 2 only. That's how market operates. That's how we are operating also in our company, using lots of infrastructure. N, you only go to licensed version. If you have a licensed version, you can go to n, you can operate, they come and support to you. Okay, third party, you have a third party support, maybe you can go up to n minus 1 as well, but not n for sure. This is how the market runs in the real world. Okay, no support n-2 for sure, 99%. You have a licensed version, someone is ready to support instantly because you're paying them, that you can go up to n also. Risk you can take it because there are people who know the product and they are ready to help you because you're paying it straight away. Here, third party people, you can risk up to n-1 also because there are some people who really support you on a subscription basis, not on the licensing basis. This is how the market operates on the Postgres. Any questions?
Ravinder, generally cloud providers have their own distributions, right, of
Yes.
PostgreSQL. So
Mhm.
if there is any issue, they are the one who need to support, right? Like for
Yes,
example,
always
data.
they go up to N because they are supporting everything. If the product is buggy, they are going to help you. You are not. It's a PaaS platform I'm talking about. If it is a cloud, it is only PaaS I'm talking about. Okay, here cloud means platform as a service, ready-made service. If it is a VM model, you can't go to that level. You have to go to n-1 or n-2 only VM side because you manage it. If it is a
Okay.
cloud PaaS model, you can go to N version because by default it is nth in the cloud. If it is a
Mm.
VM, you are managing the product. Cloud does not care about it, what you have inside. They only give you a VM object. You have to protect
Mm.
your everything you have to do yourself. So here you have to minimum n-1 or n-2 is guaranteed. You can't go to N here if it is cloud.
Okay. For example, AWS has its own like Aurora PostgreSQL, so that will be we can go up to N, and if there is any issue with the product, they are the one who need to resolve it, right?
Right. If service is going down because of any buggy thing, who are responsible? They are responsible. They will make you help you out to bring it up. In fact, they
Okay.
work for you. Their responsibility, you are putting the entire responsibility on them. You only operate on the data layer, not at the hardware layer or even management layer. They do 90% of 50% of DBA work also. Only you make it available, authorize the people, look at the performance tuning and look at the computing power and check for the the load model. That's what your job. The backups and everything is automated, upgrades are automated, monitoring is automated, everything is automated in the past model. You don't have to worry about. That is taken care by the cloud. But when it is come to the VM, they are not at all. They only give you an object, VM object. What you do inside the object, none of their business. So you have to mind your business within the VM. That's where you can't go to nth version in the VM in the cloud also. Clear? Yes.
Yes, Ravinder. Thank you.
Yeah. Come back to discussion again. Right. You all understood how the Postgres is actually progressing through the third parties only. Who are getting the money from the third party? They are collaborating in the background. They are building the product. If you see, they are releasing lot of versions. How they are able to release these new versions? Basically, if we go to downloads, how they are releasing the new versions within each version, basically because they are people are coming for the support. When they are coming from the support, they know what is a buggy thing. They are collaborating, they are making as that a patch or as an advanced or enhanced thing on top of it. Okay, that's how it is. And database limits here, database size, I want to take few minutes extra, don't mind, I'm going behind the clock because I just want to talk two slides and close. See, maximum database size is unlimited. You can grow up to your hardware capability. Your hardware is supporting well. You can grow up to whatever the level you want. There is no database capping at any point. Okay. Single table can grow up to 32 TBs. Single table, not database here. Single table 32 TB, I never seen. One table 32 TB, I never seen with all my 17 years of experience. Database I've seen, but not table. Okay, in maybe like few TBs I've seen, five up to 4 to 5 TB, one table. Maybe you might see in your career, but that's a big threshold. In fact, very huge threshold. Maximum one single row can grow up to 1.6 TB, which will grow a row. Single row can grow up to this big. Maybe like you have a blob data, image data, videos data, something kind of data can grow that big. Maximum one field side, one single field, one row column, one cell can grow up to 1 GB. Okay. Maximum rows per table, unlimited. There is no limitation. Maximum columns per table, up to maximum 1600 on the higher versions. and maximum indexes unlimited as per your number of fields. There is no limitation. As you have n number of fields, n number of indexes you can create based on the number of fields. Table relation, everything called as a relation in Postgres. I'm just giving introduction, guys. I'm not finishing anything. We will go very in depth of this product. I am not exaggerating, don't worry. I'm working on this product since very long. I'll take you through every real world thing what I went through. That's how I keep my trainings anyway. Outstanding. You can't get what I'm going to deliver in this class anywhere for sure. I'll guarantee on that for sure. A row is called tuple, column called as a attribute, data block is called page. Page is anyway everywhere. Everybody knows the same thing, right? So, right, project Nisi, why we need to learn Postgres? Because of the nature is open source. Everybody widely implementing the Postgres technology, not just Postgres, all open source. In fact, in the RDBMS, Postgres is the highest share product in the market, which is getting widely implemented than any other product because of the nature, the features that what it is giving, how the aggressively the product is getting developed. And though you don't have support, you can buy the third party support. You can go to the paid version and they are licensed anyway. You have to pay whether you go for the support or not, doesn't matter. You have to pay simply. You have to pay. That's it. There is no other way. Okay. The licensing side it works that way. So subscription anyway will be much cheaper than the license for sure. So licensed version only 5% in the entire market of the Postgres. 5% is only the implementation that you see in the real world. Okay, rest is absolutely open source, 95%. So see guys, why we need to learn Postgres open source technology? Because it's getting widely implemented. You might be working in one technology, maybe SQL, maybe Oracle, maybe MySQL, whatsoever. This is going to help you out to expand your skill set and give you more opportunities in the market, because every company has a Postgres. So everywhere you have the opportunity, as simple as it is. So learning is new technologies highly important nowadays because of multi-skilled people are more in demand nowadays. Better career opportunities, demand for Postgres. How the demand is growing means for the Postgres, the resource also will grow the demand. Obviously, they are directly proportional, right? So quickly, let me walk through the course content. We have designed this course into 23 modules. In fact, first is architecture. This is very important. Stay back as few minutes, please. Don't mind. Architecture plays very bigger role. I'm going to talk in and out of it, and this is going to be very important for us. Installations, database clusters, configurations after the installation, tools which we use, connect, security, and auditing the data, who is doing what, and logging the all operations, creating databases, table spaces, tables, indexes, backup recovery, routine maintenance. How do you do the, this is where about I was talking about MVCC. I'll explain in detail here. Okay, data dictionary, what kind of default tables we have, how they help to monitor the like system performance, importing exporting data, streaming replication, all high availabilities will be discussed here. Auto failover, uh, table partitioning, extra features if you want, and linked servers if you want to create, upgrade, GUI tools, automatic failover, monitoring. So that's how it is going to be. This is more than enough for any advanced DBA to support any environment. In fact, I kept this entire course keeping in a mind that I am working, what I am doing it. Based on that, I build the course, in fact. Okay. So that's how it's going to be. So be regular to the class. That's important. So before I stop the recording, anybody want to ask something? And then I'll talk after.
Yeah, Ravindra, like regarding that course content, right? Will you able to cover patching also, right?
Yeah. Oh, that's very important, of course.
Patching and something I heard in Google like vacuum some.
Vacuum, very important. Don't worry. You name it, you have in the course anyway. You go to the content.
Yeah. And when like in whatever that the scenarios you are explaining in real world scenarios, right?
Mm, mm, mm. Yeah,
Okay. Yeah.
those will be explained. That's where my focus will be. I don't focus on the theory at all. Theory we will see only in the architecture. Rest of the discussions are all purely practical oriented. No, I don't focus on the theory. You can get it anywhere. That's how I keep my trainings outstanding. You definitely feel
Okay.
it. I don't have to exaggerate, but you feel it by the end of the course for sure.
Yeah,
Okay.
even that cluster configuration, like primary and standby, that also.
Yes. Automatic failover will shut down the primary. Second will take automatic. We have 6 types of high availabilities. I'm going to talk about all of that. Okay.
Okay. Yeah,
Don't worry.
troubleshooting part also, right? We'll cover, right? Mm,
Configuration, then troubleshooting. Obviously,
yeah, thank you.
everything with
Ravinder,
troubleshooting. Go ahead.
yeah, we do have a few enterprise like EDB and Percona, so it will be same as this one, right?
Yes,
Not only
here and there. Very few things here and there. If you know one, you know
okay,
all. Because they are evolved from here only.
okay.
Yeah. I'm stopping the
Hello,
recording.
hello.
Yeah, go ahead.
Do we have recordings for this course?
Just a minute. I'll talk that offline, okay?